In this video, we're going to have a discussion about the types of sets of numbers that exist in this real world. So we're going to talk about the real numbers. And the real numbers are basically numbers that you can see, that you can use to quantify things, that you can use to, well, count stuff. So real numbers are split into what are called irrational and rational numbers. What's the difference? Well, the formal definition is that a rational number is any number that can be written as a ratio of two integers, right? Remember, integers are all the whole numbers and their opposites. So if we can't write a number as a ratio of integers, then it's considered irrational. But there's an easier way to be able to tell. So you get out your calculator if you need to, or even just use your noggin, and you're usually able to figure out if something's irrational or not. So the irrational numbers that you're going to be exposed to, at least in the next course or two, will be square roots, pi, and this number called e, which is coming down the road. So pi is considered irrational. How do we know that? Well, pi cannot be written as a ratio of two integers. Well, okay, so what does that mean? What that means is the decimal pi keeps going on and on forever, but has no pattern to its decimal. So 3.14159, and it keeps going, and you can't look at the decimal and say, oh, I know what number comes next. So that makes it irrational. Other examples of irrational numbers are square roots that do not have nice answers, meaning when you take the square root of the number, you don't get a whole number back. So, for instance, the square root of 7. When you take that, you're saying, well, what number when multiplied by itself gives me 7? And there is no nice number that gives you back 7. So that 7, we call that not a perfect square. We've talked about that earlier. And since it's not a perfect square, it is an irrational number. How do you tell that from a calculator? Do the square root of any number, and if you get a decimal back that is non-repeating, doesn't have a pattern, and does not end, then you know that that square root is not rational or irrational. So other examples, you could do like negative square root of 17, or heck, the square root of 32. None of these are perfect squares. So what are some rational numbers? Well, here we've got the number sets, and I've kind of written them inside of each other. You've got irrational and rational, all considered real numbers. Within the rational numbers, these are decimals that either have a pattern and go on forever, like 1/3. As a decimal, that's 0.3 repeating. It keeps going on and on. You can predict what the next decimal is. Or we could have a decimal like negative 0.72, 72. And so on and so forth, and it keeps going. Or it can be a terminating decimal that ends. So that could be like, oh, I don't know, 5/2, which when written out is equal to 2.5. So that's a rational number. Think ratio null, a fraction in the number. So we can write all these numbers as fractions of integers. How you tell again? Does the decimal end like this? Or does it repeat? It has a pattern even though it goes on forever. So these are all considered rational numbers. Now within the rational numbers are sets of numbers that are called integers. So these are all families of numbers called sets, groups of numbers that fall within the rational number category. So for instance, integers, that would be any positive whole number, 0, or the opposites of all those positive whole numbers. So I'll dance them around here like -3, 0, the square root of 4, right? Because that's equal to 2. It's a rational number and it's also an integer. -17. These are not considered integers because, well, they're not whole numbers or their opposites. 0, as I pointed out, is an integer. Then finally, you've got your whole numbers, which are all the positive values, and 0 that fall in the integers. So that would be like 0, 1, 2, 3, and so on and so forth. These are all considered sets. So to talk about these a little bit, we could put them on a number line as well. So I'll put them right here. And then what we'll do on the flip side of this video is I'm going to give you a few numbers, and I'm going to leave this up here, and we're going to classify those numbers in the sets to which they belong. So if you've got a number line, right, 0, 1, 2, 3, and so on and so forth, and then -1, -2, -3, and so on and so forth, all of these numbers are considered the integers. All of the numbers 0 and greater are whole numbers, And every single one of those numbers and any decimals that fall into the category of what I call rational, they're all in this number line, are considered rational numbers. So integers are rational, whole numbers are rational, and numbers that are neither whole numbers or integers can be rational. Irrational numbers fall in this number line too. For instance, the square root of 7 is between the square root of 4, which is 2, and the square root of 9, which is 3. So the square root of 7 is somewhere like right here. It's still irrational, but it's on the number line. So real numbers are numbers that can be counted. They're on the real number line. But to be very, very frank about it, you can follow these definitions and understand how these values are grouped together. So that's an introduction or maybe reintroduction into the real numbers and how they're split up. Very cool. On the flip side of this video, we are going to just classify 3 or 4 numbers using our knowledge here as real numbers, rational, irrational, and the like. See you on the flip side. And here we are on the flip side of the video, where we are going to use our knowledge now of how real numbers are classified to actively classify each of these numbers in as many ways as possible. Let's check it out. So the square root of 32. Well, we looked at this in our original example here, and we deemed it irrational. Why is it considered irrational? Because 32 is not a perfect square. In other words, there is not one number that when multiplied by itself will give us back 32, not one whole number. So it is considered irrational. So we would write that word right there. I'm just going to say it out loud. You don't have to watch me write things. So this is considered irrational. Now the square root of 100, that can be simplified to 10 because 10 times itself is 100. And 10 is considered a whole bunch of different numbers. So 10 is in a bunch of subsets of the real numbers. Subset means smaller sets or the same size groups of numbers that fall within the real numbers. So that would be a whole number. 10 is certainly 0, 1, 2, 3, 4, 5. It belongs to that. It therefore belongs to the integers. So this number is an integer. It is also a rational number and a real number. So it's everything. It's all the above. Negative 3.26. That's a decimal that ends. It terminates. And because it terminates, it is considered rational. And so we look at that and we say, well, is it an integer? No, it's not the opposite of a whole number. So the most specific name we can give it is a rational number, which of course is a real number. And finally, you have 7/5. 7/5 is a fraction. It does not simplify to a whole number or an integer. So it is also considered just a rational number. Since it can be written as a fraction of 2 integers, we know that it's at least a rational number. That's it, peeps. That's how to classify using our number systems, real numbers between irrational and rational. Go rock some classification problems.